This is our next installment in identity proofs with trig identities. And so as you see here, I've got my toolbox over on the right, and on the left are my 6 problems I'm going to be working on. So what I'd strongly encourage you to do, just like I've been saying before, is pause it, write down these 6 problems, and see if you can do them without me doing it for you. You're going to get so much better at this if you don't just watch me do it for you. You get better by learning by doing. Also, just so you know, there's a good chance, because they're getting a little harder, that I might go down the wrong path at some point, or maybe won't take the most efficient path. You might do something differently, and you might find a quicker way than I did, and you might be right. So that's okay. There's not always one correct way to do these trig identities. All right, so let's get started with number 11. Once again, if you haven't paused it, written them down, and tried them on your own, you probably should do that first, and then watch this and see if you got them. So, with number 11, let's zoom in on that one. We've got secant A minus tangent A in parentheses, and then times secant A plus tangent A in parentheses, and that equals 1. Well, one thing I said on a previous video of these trig identities is you can work with either side of the equal sign and try to make it into the other side. Well, it's hard to say let's start with 1 and get that stuff over on the left. So I think what we're going to try to do is turn that stuff over on the left into 1. So we're going to work on the left side here. And what I'm seeing here is I want to FOIL. And if you're not familiar with foiling, all that means is just distributive property, double distributive property. So first times first, first times last. So that would be secant squared A plus, and then secant A times tangent A is just secant A tangent A. That's a tan. And then we'll distribute the tangent A as well. And it's a negative tangent A. So minus tangent A secant A. Looks like I'm running out of room here. And then minus tangent squared A. And typically we'll put an equals there. All right, well, if you notice, let's grab green here. This and this are the same, except one's positive and one's negative. It's secant A times tangent A, and it's tangent A times secant A. And since multiplication is commutative, those two are the same. But since one's positive, one's negative, they basically just cancel out. So our next step is going to be secant A minus tangent A. All right. And so secant A minus, excuse me, I forgot a big step there, didn't I? I forgot squareds. It's secant squared A minus tangent squared A. It's kind of a big deal. You kind of need those. So this is looking like it might be over on my little toolbox over here. Do you see secant squared A minus tangent squared A anywhere? And I see that right over, whoa, let's grab the pen over here. There we go. Let's see. I think that's a good color. I see it right there. Secant squared minus tangent squared is 1. And so the nice thing is over here, this is just 1. And we're done. We can just say right there that equals 1 because that's part of our trig identities toolbox that we've proven that one already, so we can use it. All right, number 11's in the books. Let's look at number 12 here. We've got cosecant x minus 1 equals cotangent squared x over cosecant x plus 1. So this might be an example of one where working with the left might not be the best choice, because how am I going to get all of this stuff given just cosecant x minus 1? Now, I think you could, but it might be a little bit tough. What I'm thinking is you might change the cosecant x into 1 over sine x, and then try to get a common denominator. It might work. What I'm going to do is I'm going to work with the right side instead. So let's do cotangent squared x over cosecant x plus 1. All right. So sometimes if you see like the top thing, I'm thinking maybe I'll use the Pythagorean identity. But with the bottom thing, there is no squared. So maybe I'll just try to change it all into sines and cosines. So that top part, cotangent squared x, is going to be cosine squared x over sine squared x. And then cosecant x is going to be 1 over sine x plus 1. Okay, so I think I just made this fairly messy. What I think what I might do next is take this bottom stuff and get a common denominator. Let's see if that does anything for me. So on top, we still have cosine squared x over sine squared x. On bottom, I'm going to have 1 over sine x plus sine x over sine x, because I want to get a common denominator. Let's see if I have room over here. I want to bring this up over here. Cosine squared x over sine squared x. All of that over 1 plus sine x over sine x. Okay, well, this is not looking good, because I need to get cosecant x minus 1 somehow. I'm struggling to see where this is going to go, but what I'm going to do is I see a fraction on top divided by a fraction on bottom, and so I'm going to multiply by the reciprocal, and that's going to get us to less fractions, hopefully. So we've got cosine squared x over sine squared x times sine x over 1 plus sine x. Well, one nice thing here is if these are multiplied, excuse me, let's do something to contrast a little better. This sine x on top here can cancel out with one of those sine x's on bottom there. So what we're going to have in our next step is cosine squared x over sine x times 1 plus sine x. This is already getting to be pretty messy. And we're trying to get to cosecant x minus 1. So I'll be honest, I don't know if this is going to get me there. I mean, I could distribute this. Let's do that. Let's just see what happens here. Cosine squared x over sine x plus sine squared x. I'm not seeing it. So I'll be honest, I purposely went down this path. I know a quicker way to do this one, but I purposely went down this path to see if I could get there. And I think we kind of have hit a dead end. We might be able to. I'm hemming and hawing here. Let me tell you what I'm thinking. Is maybe I can change cosine squared into 1 minus sine squared, and then actually that will work. I'm seeing a couple steps ahead here, so let's do that. So this is going to be, I'm going to change the top thing here. I think this will work. So this is, and I'm going to show you a quicker way to do this one than this, 25-step process that I'm doing. So this is 1 minus sine squared x over sine x plus sine squared x. I'm kind of bleeding into the next workspace, but that's all right. So one thing that you may not see this top is factorable. It is the difference of two squares. So it's going to be 1 minus sine x, 1 plus sine x. That would be the factors of the top. And on the bottom, that's also factorable. We could pull out a sine x. And so it would be 1 plus sine x. So what I can do is cancel out the 1 plus sine x on top and bottom, because if you notice, they're multiplied by things, so you can cancel those out. So now we end up with 1 minus sine x over sine x. Now, if you have a fraction and there's a plus or a minus on top, you can separate that fraction. One of my math colleagues says, if it looks like a heart, you can take it apart. And then if you have a positive on the bottom, or excuse me, a plus or a minus on bottom, he'll say if it looks like a butt, don't touch it. So this one looks like a heart, so you can take it apart. If it looks like a butt, don't touch it. Remember that rule. So what we can do is we can take this apart. And what I mean by take it apart is this becomes 1 over sine x minus sine x over sine x. And the reason you can do this, if you think about like 1 plus 3 over 4, that's 4 over 4, right? Well, that's the same as 1/4 plus 3/4. That's 4/4. However, if you do it the other way, it will not work. Let me try that again. So if we had, let's just do the exact same numbers, but reverse. So let's say we had 4 over 1 plus 3, that's 4/4. But if you do 4 over 1 plus 4 over 3, that is 5 1/3. That's obviously not the same as 4/4. So looks like a heart, you can take it apart. Looks like a butt, don't touch it. All right, so let me get rid of these. We are super duper close to our final installment of this proof. And so 1 over sine of x is cosecant x. Sine over sine is 1, and we got to where we needed, just like I said, 25 steps later. Okay, so that was a lot. And you know, a lot of times when I go over this with my students, they're like, oh my gosh, that's crazy. How are we supposed to do that? Well, you just keep going. You notice how I kind of got to a point, I was like, man, I don't know how I'm going to do this. This is a lot. Just keep, you know, doing your steps, factoring and distributing, stuff like that. Eventually, it'll all come together. And if it doesn't, you go back to the beginning and you start over. So what I'm going to do is I'm going to get rid of this stuff because I want to show you a different way, and I don't want to have this stuff in the way, so it's just going to take me a second here. I'm going to pause the recording and I'll get it all set. All right, so just like a cooking show where, you know, like magic, it all started over. So I said there's a quicker way to do this. I didn't mean to write cosine. Cotangent squared x over cosecant x plus 1. All right. So what we're going to do is the quick way to do this is we're going to change that top. If you notice, cotangent squared is cosecant squared minus 1. So I'm going to change that top into cosecant squared x minus 1. Now it's super tempting to want to cross out a cosecant and say the 1's cancel out, but algebraically that's not okay. Like oftentimes when I give this problem to students, what they'll say is they'll just say, oh, we can cross out a cosecant, and then you just get cosecant x minus 1. Well, that doesn't work, I'm sorry. Those are not legal algebra steps. So what we're going to do is this top we can factor, just like I talked about in my first solving of it. And this is cosecant x plus 1, cosecant x minus 1. And now, just like in the last steps of my first attempt to solve this, Cosecant x plus 1 and cosecant x plus 1 are identical on top and bottom. You can cancel those out. And what are we left with? Cosecant x minus 1. How cool is that? Beautiful math right there. All right, and we got to the left side, so we are good to go. So that one was just, let's see, 1, 2, 3, 4 steps. The other one, I think I must have been somewhere around a dozen steps, maybe even more. All right, number 13. 2 problems in, and we're 15 minutes in. Holy smokes. All right, this one is just screaming FOIL again, just like the first one. So I'm going to distribute. We've got cosecant times secant, cosecant theta times secant theta, and then cosecant times 1, so plus cosecant theta. And then we'll distribute the negative cotangent theta. So that's going to be minus cotangent theta secant theta, and then minus cotangent theta. And we want to make all of this stuff cancel out to just tangent. And we're going to do it. So I don't see anything that would tell me that we're working in the bottom part of this, because I see no squareds happening right now. So I'm going to convert everything that we have to sines and cosines. Cosecant times secant, well, that's going to be 1 over sine of theta times 1 over cosine of theta, plus cosecant theta is 1 over sine of theta. Cotangent is cosine over sine, so cosine theta over sine theta. And secant is 1 over cosine theta. And then cotangent is still cosine theta over sine theta. Trust me, this will all work down to be just tangent, but right now it looks like it's getting even worse. But we're going to be okay in the end. One thing I do want you to notice here is these two. You notice how those have 2 fractions that are multiplied? So we're going to combine those just to clean it up a little bit. This is 1 over sine theta cosine theta plus 1 over sine theta minus, on top we have cosine theta times 1, so that's going to be cosine theta over sine theta cosine theta, and then minus cosine theta over sine theta. So what I'm thinking here is if I can get a common denominator, then I can combine all of these fractions into just one fraction, and hopefully things will cancel out at that point. And so what I'm noticing is if I want to get a common denominator, we've got a sine theta times cosine theta. So basically what I'm going to do is multiply by cosine theta on top and bottom on that one. And same thing here, cosine theta, cosine theta. So let me rewrite that big mess that we created. We've got 1 over sine theta cosine theta plus cosine theta over sine theta cosine theta minus cosine theta over sine theta cosine theta minus cosine times cosine is cosine squared theta over sine theta cosine theta. So now that we have a common denominator, we can combine all of these fractions and make them just one fraction. So what that means is we're going to have 1 plus cosine theta minus cosine theta minus cosine squared theta. All of that over sine theta times cosine theta. I'm forgetting my equals here. Equals. Each of these things, each of these steps are equal to each other. All right, believe it or not, we're actually pretty darn close to the home stretch. The cosines are going to cancel out because one's positive and one's negative. So what we're going to be left with is 1 minus cosine squared theta over sine theta times cosine theta. And then I'm just going to write the next step. I'll just switch colors so you can kind of see that. I'll write the next step next to it. 1 minus cosine squared theta is right here. I've got a big mess working here. Let me get rid of this stuff. There we go. So 1 minus cosine squared is sine squared. So this is sine squared theta over sine theta cosine theta. Well, what we've talked about is that sine squared is sine times sine. So I can cancel out a sine on top and bottom. And look what I've got. I've got sine theta over cosine theta. And what does that equal? It equals tangent. So we got there. We wanted to show that it equals tangent, and it does. So this one was a little bit, it was a lot of steps. Looks like we had, let's see, 1, 2, 3, 4, 5, 6, 7, maybe 8, 9, 10 steps or something like that. That one was tough. It was, you had to really, and you had to see that we had to get a common denominator. That was kind of the trick on this one. All right, number 14. So, man, this one can be a little bit tricky. And so you can work with either the left side or the right side, whichever one you want to work with. And I think either one would be fine. But I'm going to try to use that trick that we talked about. And this one looks like a heart, so I can take it apart. And let's see if I can get to the right side. So I'm going to do that. I'm going to do cotangent theta over sine theta cosine theta minus tangent of theta over sine theta times cosine of theta. Okay, so cotangent is cosine over sine, and then we'll just leave the bottom. Sine theta over cosine, or sine theta times cosine theta. And then tangent, I don't want to write tangent. I want to write it as sine theta over cosine theta. On the bottom, it is sine theta times cosine theta. Okay, let's do a little bit of fraction understanding for just a second here. So if I had 1/2 divided by 2. So let's think about that in terms of a picture. What would that look like? So let's think of a pizza. And I took 1/2 of the pizza right there. And I divided it into 2. Maybe I should switch up. Let's do green. How much would I have? Well, I would have 1/4, right? So what you can say is that 2, the 1/2 divided by 2, that 2 basically goes to the bottom and multiplies with that one. And that is a solid trick to learn. We could also look at these as fractions and multiply by the reciprocal. We're going to use that. And so what is going to happen is this sine is going to get multiplied on the bottom, and the cosine is also going to get multiplied on the bottom. And so we're going to have on the first fraction cosine theta over sine squared theta cosine theta minus, and on top, sine theta, that's that guy, and then on bottom, sine theta cosine squared theta. You might be seeing where I'm going here. So cosines can cancel out. We got 1 over sine squared theta. Sines are going to cancel out, and we've got 1 over cosine squared theta. Well, what's 1 over sine squared? That is cosecant squared. And what's 1 over cosine squared? That is secant squared. And that is exactly what we needed to get to. We had to get to cosecant squared theta minus secant squared theta. So really understanding how fractions work, all that stuff is coming into play here. Looks like we got 2 left here. This video is getting nice and long. Hopefully you're sticking with me here. Number 15. I'm obviously going to be working with the left because there's no way I could take sine and somehow figure out how to get all of that crap over there. Pardon my foul mouth. So what I'm going to try is, I don't see anything that would resemble using the bottom part of this right now. We might later, but what I'm going to do now, since I don't see any Pythagorean identities, then I'm just going to switch everything to sine and cosine and see what happens. So I'm going to change the cotangents into sines and cosines. Sine theta, cotangent is cosine theta over sine theta, and then plus cosine theta. All of this stuff over 2 times cosine theta over sine theta, because cotangent is that. Okay, well, I'm thinking I'm already seeing where this is going to go. Like, look at this for a second. Maybe pause the video and see if you can kind of see the next couple steps. It's actually going to go pretty quickly. What I'm noticing is sine is like sine over 1. We can cancel out the sine on top and bottom there. And so what's going to happen is, on top we're going to have cosine theta times cosine theta, or plus cosine theta. I said that wrong. Over 2 times cosine theta over sine theta. And so what is cosine theta plus cosine theta? Well, that's 2 cosine theta over 2 cosine theta over sine theta. Well, the 2's are going to cancel out, and we're going to have cosine theta over cosine theta over sine theta. And whenever you're dividing by a fraction, you can multiply by the reciprocal. So this would be cosine theta times sine theta over cosine theta. And we have a cosine on top, a cosine on bottom, and guess what we're left with? Sine of theta. Sorry, that got a little messy. Let me rewrite that. Not much better. There we go. Sine of theta. Cool. So multiple steps, a lot of steps, but that one just kind of fell into place there. Okay, last one here. We've got tangent squared x over 1 plus tangent squared x, and that is going to somehow simplify into sine squared x. Okay, well, I'm seeing a bunch of squareds, and I'm thinking it's got to be down in the bottom part of my toolbox here. Is there a 1 plus tangent squared? And yeah, there is. It's right here. So let's switch that. Let's see what happens. So 1 plus tangent squared is the same as tangent squared plus 1. If it was a subtraction, if it was 1 minus tangent squared, that wouldn't work. So like looking right below here, if you had 1 minus secant squared, you can't say that that's tangent squared. That's different. Okay, so let's change the bottom here. We'll have tangent squared x on top, and this will be secant squared x. So then what I think I'm going to do is I'm going to use these things, those 2 identities. So tangent squared x would be sine squared x over cosine squared x, and secant squared x is 1 over cosine squared x. Well, like we've talked about a few times, when you're dividing fractions, you can multiply by the reciprocal. And so this is sine squared x over cosine squared x times the reciprocal of the bottom, which is cosine squared x over 1. And we can then, if we have cosine squared x on top and a cosine squared x on bottom, Those cancel out, and look what we're left with. Sine squared x over 1, which is sine squared x. All right, that was a long one. It's only 6 problems, but it took us over a half hour. Hopefully that helped. Each one is unique, and like I've been saying through all of these, there isn't a magic formula or algorithm to solve all of these. You just really have to know your fractions, try stuff. As you saw in the second example, I got down a path and it was pretty ugly. It worked out, but there was a quicker way to do it if I noticed that right away with the factoring thing. Anyway, hope this is going all right. Those are those 6 problems.